This is Billy the Magic Pencil, and today we're going to take a look at the quadratic. And you guys probably already know that the parent for the quadratic is just the parabola, y is equal to x squared. And the first look I'm going to take at it, I'm going to ignore everything up here, and I'm going to do just exactly what we had done a couple of chapters ago. So I know the parent for this thing is y is equal to x squared. Now I also take a look at it and I notice it's upside down, or it's been reflected over the x-axis. So I'll put the reflection in. It would be y is equal to the opposite x squared. Now I'm going to take a look at the shape. So I start on the vertex, and I know when I go 2 to the left right here, I go 1 down. Or if I go 2 to the right, I go 1 down. Well, that's a scale change of 2 along the x-axis, so I'm going to put that in there. Take x and divide it by 2, scale change of 2, x-axis, and then the vertex I notice is not at 0, 0, but it's been moved 2 to the right and it's been moved 4 up. So I'm going to do that in my equation, and I know that if I want to move something or translate something 2 to the right, I replace the x with x minus 2. And if I want to go 4 up, I add a 4. Now back in the chapter where we're doing scale change and translation, this had been where we'd quit on this, but I'm going to expand this right here. I'm going to do that square, and at least I'm going to do part of it. So I'm going to rewrite it in the numerator. I'm going to leave x minus 2 squared. Denominator I'm going to square, and I'm going to write it a 4. And then I'm going to rewrite this first term right here. This is a negative 1/4. And it's x minus 2 squared plus 4. And you notice this form that I've written right here matches this form that you see up here called vertex form. And again, when you read this, or when we were doing this back in whatever chapter it was, you'd look at this right away and know we're going 2 to the right and we're going 4 up. You put the vertex at 2, 4. But this one we would have ridden, whatever you want to say, as a scale change of negative 1/4 along the y-axis. And what that's telling you is that when you go 1 to the right up here, you're going 1/4 down, quarter of a square. Or if you go 1 to the left, you're going down a quarter of a square. Scale change of 1/4 along the y-axis. Now we're going to take a second look at this, and I think by the time we get midway through this chapter, you're going to see what I'm doing and why I'm doing what I'm doing right now. But I want to use, without justification, I just want to use this vertex form where h right here is the first coordinate of the vertex and k is the second. And we'll worry about a in a little bit here. So I'm going to rewrite this by putting the first coordinate of the vertex in for h, be minus 2 right there, and the second coordinate of the vertex in for k. Right there, that's vertex form. That's just what we did before. Now, I'm going to pretend I don't know what a is. But I've got this other point right here, 0, 3. Now this could be any other point. It could have been over here, it could have been 4, 3, and this would have worked just as well. Or I could have used, down here, I could have used 6, 0. It doesn't matter. But I'm going to use 0, 3, which is the y-intercept. The y value is 3, so I put that into the equation. X value is 0, I'm going to put that in too. And now I'm going to go and solve the equation for a. So I got 3 is equal to a times, and this is a negative 2 squared, it's going to end up being a 4, plus 4. My equation is 3 is equal to 4a plus 4. I'm going to subtract this 4, and I get negative 1 is equal to 4a. I'm going to divide by 4, and I get a is negative 1/4. And now I'm going to put that negative 1/4 in right there. So I got y is equal to negative 1/4 x minus 2 squared plus 4, and it's pretty easy to do. If you're given a vertex and another point, getting an equation in vertex form is a real simple thing, and you can see it right there, and it's a very valuable form for the quadratic. Now the next form of the quadratic that we're going to take a look at is factored form, and this is another valuable form, and it's a real easy form to work with. And over here, when I take a look at the graph, the 2 points where this graph crosses the x-axis right there, -2, 0, and 6, 0. The -2 and the 6 are called the roots of the quadratic. It just tells you where you're crossing the x-axis, or it's telling you what values of x will make y 0. Now the other term for that is zeros, and they're used fairly interchangeably. And I've also got the point 0,3 on my equation right there. Now I'm going to use this form, and I'm going to use it without justification, and I'll show you at the end that it's actually a legitimate form. So I take the first root that I see, which is the -2, and I just plug it in. So here I've got x minus -2. And over here the second root that I see is 6. I just write x minus 6. Very simple thing to do. I'm going to rewrite it. So this is a times x plus 2, and a lot of people will do this right away with the negative root. They'll just write x plus 2 and x minus 6. Now again, I don't know what the a is, so I'm going to go up here and I'm going to use my point 0,3, and I'm going to do the same thing I did before. I'm going to put the 3 in for the y. I'm going to put a 0 in for x, and you guys know that 0 plus 2 is 0, so I'll get a 2 right there. And you also know that 0 minus 6 is -6, so I'm just going to write that. So now I have 3 is equal to, and this is a -12, -12a. That tells me that a is equal to 3 divided by -12. I simplify my fraction. It tells me a is -1/4. Same thing I got the last time. In my equation now, and this is the factored form of the quadratic equation, it's -1/4, which gives the parabola its shape, x plus 2 times x minus 6. Factored form. Right there. When I'm reading the factored form, I know I'm crossing the x-axis at -2, because -2 will make this factor 0, and I'm crossing the x-axis at 6. 6 will make that factor 0. Now the last form that we're going to take a look at is general form, and I think this is the more difficult of the forms to work with. Now before I start this, if you're given, you can see the 3 points that you're given up there. If you're just given 3 points and nobody tells you how to do the problem, you just take those 3 points, go to L1 and put in the 1, the 5, and the 7. Go to L2 on your calculator and put in the 3.75, the 1.75, and -2.25, and go and run quadratic regression, and run it on L1, comma, L2. You've done that for a long time. Your equation will just come right out of your calculator. You just write it down, away you go. Not very hard to do. Now we're going to take a look at this equation again, and this time we're going to get the equation general form, and we're going to do it by hand. And you're going to do it by hand because sometime, somewhere, somebody is going to make you do it, probably sooner than later. Right now we're going to start with this point right here where x is 1 and y is 3.75, and we're going to go over to the general form where you see an x, you're going to put in a 1. You know that 1 squared is 1. I'm going to put a 1 here, and you know 1 times b will just give you b. So I've got an equation. it says A plus B plus C has to be equal to, and the y value is 3.75. Okay, now I'm going to do the same thing with this point with 5, 1.75. I'm going to put a 5 in for x. This will be a 25 right here, and a 5 right there. Okay, and I'm going to write that. So I'm going to have 25a plus 5b plus c is equal to 1.75. And I'm going to do it with 7, negative 2.25. When I put the 7 in for x, I'll get a 49. I'll get a 7b right there. So now I've got 49a plus 7b plus c is equal to negative 2.25. Right there. Now, when I solve this, I could use elimination, I could use row reduction, you could use matrices on your calculator, you could use substitution. I'm going to decide, just for the heck of it, I'm going to use elimination. It doesn't really make much difference, just choose what you like. Now, the thing I'm going to do with this is, I notice right here, if I just take c away from c, I can get a 0, so I think I'm just going to subtract. And I'm going to take the top equation away from the second equation. So I'm going to take 1a away from 25a, and right here I'm going to get a 24a. I'm going to take 1b away from 5b, get a 4b. I'm going to take c away from c, I'll get a 0. I'm not going to write that. And I'm going to subtract 3.75 from 1.75, and I'm going to get a negative 2. Okay, so I've gotten rid of c from one equation. Now I think I'll do exactly the same thing, but I'll do it with these two equations. I'll take the second one away from the third one. Right there, so I'll subtract those two. Now when I take 25 away from 49, I get a 24a again. When I take 5b away from 7b, I get a 2b. c away from c, I get a 0. And now I take 1.75 away from negative 2.25, and that'll give me a negative 4. Right there, and that's the one subtraction that you might have to go back and take a look at. Now I notice again, if I just subtracted, I could get rid of the a, so I think I will. I'll take 24a away from a, I'll take 2b away from 4b, that'll give me a 2b. And I'll take negative 4 away from negative 2. Negative 2 minus negative 4 is 2. And right now I know that b is equal to 1. So I've got one of my coefficients. Now I'm going to pick one of these two equations, and I'll do it. I think I like this one right here, and I'm going to put 1 in for b and solve it for a. So I'll get 24a plus 2 times 1, that's just a 2, is equal to, up here, negative 4. That tells me that 24a, I'll add a negative 2 to both sides, should be a negative 6, and a should be negative 6 over 24. Simplify the fraction, a is negative 1/4. Had that before. So now I've got two of them. I got to go get my third coefficient. I think to get the third coefficient, I'll use this equation up here. So for the a, I'll put in negative 1/4. B, I'm going to put in a 1. I'm looking for c, and this should be equal to 3.75. I'm going to add these two, and I think I'll do it as a fraction. So I get negative 1/4 added to 4/4. So over here I've got 3/4 plus c. I'll write this as a mixed number. This is 3 3/4. Now I can subtract 3/4 from both sides, and I get c is equal to 3. So I've got a down here at negative 1/4, b at 1, and c at 3. And my equation in general form is y is equal to negative 1/4 x squared plus 1 times x, which is just x. That's b that would go right there, plus c, which is 3. And I've got an equation in general form matches this form up here. Now, general form, there's two things that you can pick out of general form right here. This number is the y-intercept. It tells you that you're crossing the axis. Right there. Reason for that is we put a 0 in for x. Both these terms are 0. Y is equal to 3. And this number right here gives you the shape of the quadratic. Tells you if you can find the vertex, you can go 1 to the right and 1/4 down, and you got your shape out of that. Now the last thing I've got to do is I've got to show you that all three forms of this quadratic are exactly the same, and they all do the same job. So I think what I'm going to do is I'm going to leave the top equation here alone, and I'm going to start with this one, and I'm going to transform this equation into this form right here. So I'm going to rewrite it. I don't know why I'm rewriting it, I guess because I got the pencil and I can. And this becomes then y is equal to negative 1/4. And if you've forgotten this from the 9th to the 10th grade, I'm going to write out x minus 2 squared as x minus 2 times x minus 2. And then I'm going to multiply these two binomials together. First multiplication will give me an x squared. Then I'll get a negative 2x and another negative 2x. That's negative 4x. And then negative 2 times negative 2 will give me a 4. And now I'm going to distribute the negative 1/4. And when I do, I'll get a negative 1/4 times x squared. I'll take negative 1/4 times negative 4. That'll give me a 1x. Negative 1/4 times 4 will give me a negative 1. And I still have to add my 4. So this equation now is negative 1/4 x squared plus x plus 3. Voila. It looks just like the one that you see up there. Alright, last thing we got to do, let's take a look at factored form and show that factored form is the same as the general form up here. So I'm going to do the same thing I just did. I'm rewriting it. Again, I'm doing this because I can. And I'm going to multiply the two binomials together. First multiplication will give me an x squared. Second multiplication will give me a negative 6x. Third multiplication will give me a 2x. And the fourth multiplication will give me a negative 12. Now I'm going to combine like terms. So I've got an x squared, negative 4x, and a negative 12. Multiply through with a negative 1/4. And negative 1/4 times negative 4 right there will just give me a 1. Negative 1/4 times negative 12 gives me a 3. This equation matches that one. All three of them are identical. All three of them will do exactly the same thing. Now the last thing we'll mention is the value of each one of the individual equations. I think one of the most useful and one of the ones that I like the best is vertex form. I think vertex form is very easy to work with in a lot of problems. You know, it tells you an awful lot about the quadratic. Whether you find the vertex right there, you got the axis of symmetry, you got the shape. I think it's an easy form to work with. The other thing I think makes the form so nice, and you'll see this later on, is the x appears in it only once. It just shows up one time. Right there. Valuable form for the quadratic. In my mind, the second most valuable form right here is probably factored form. It's because there's a lot of times you're going to want to know the value of x that will make y 0, whether you're doing a problem where you're throwing something up in the air and you want to know when it hits the ground, when the height is 0, whatever it might happen to be. And it's real easy to see right here. You can tell if you put a -2 in right here, -2 plus 2 is 0. And if you multiply three numbers, one of them 0, you're bound to get a 0. And 6 will make this 0. So I've got the two values that'll make y 0 right there. I can see it, and I've got the shape of the equation right there. When you look at the general form, the thing that you've got in general form that you don't have any others is probably right here. That's the y-intercept, and that tells you if you're going to go and you're going to graph this thing, that when you hit the y-intercept right there, it'll be at 3. But as the forms go, this is probably my least favorite. But it doesn't have to be your least favorite.